Hello. This video we're going to go ahead and finish the rest of lesson 1-3, and we covered this on September 2nd, 2016. Now, I had you turn in your do nows, so I had you write this on a separate sheet of paper, and we basically went over the names of each of these inequalities. So this is less than, and a really quick note, this looks like a nail, so this is going to be less than. And whenever we have the line underneath the less than, it's less than or equal to. That means by default this is going to be greater than, and this is greater than or equal to. Now, when we graph these on number line, whether you use less than, greater than, or less than or equal to, or greater than or equal to, is going to matter. It's going to be very important. So whenever you use less than or greater than, you're going to use open circle. And when you use less than or equal to, or greater than or equal to, you're always going to use a closed circle. So very important. Alright, number 2. Now, we went over this in the previous video, but might as well reinforce those ideas. Whenever you have an absolute value less than a number, you can go ahead and take this number right here and find the positive value and the negative value. Now, remember that since we have less than, going back to my paper here, my box, whenever I have less than, I'm going to use open circle. So that's why I have open circle on both of those. Okay. We also want to write the numbers out. So we have 5 and 5. It's very important that the smallest number is on the left. And the largest number is on the right. This is going to be the inequality that we're writing right now. This is the inequality, and below here is the graph. Okay, now basically to get the inequality, you take whatever's inside the absolute value, put it in the middle, and this inequality basically is going to go on both sides. So here is the inequality form. So you take whatever's inside the middle, inside the absolute value, put it in the middle, and you take this number and write it out twice, where on the left it's negative and on the right it is positive. There's a fundamental idea about that we'll use later. And here on the number line we have our two solutions. That we have open circle, and because the inequality is less than, we're going to have to shade on the inside. Now, why are we shading on the inside? Well, think about this. We basically part of the what this is saying is that we're looking for numbers less than 5. So what numbers are less than 5? Well, that's basically 4, 3, 2, 1, and 0. And when we start getting into negative numbers, we have to use the absolute value of those negative numbers. And when you take the absolute value of -1, well, that's still less than 5. All these numbers inside. So basically, if you see that the numbers are being shaded, are being on the inside of both of the solutions, then you shade the whole inside of it. Okay. So whenever you have less than, you basically shade inside. Same thing for when we have the absolute value greater than 5. First of all, let's go ahead and put our two solutions on the number line, open circles for both. Again, we take whatever is in the middle, inside the absolute value, put in the middle. We write our two answers. The smallest one goes on the left, the largest one goes on the right, and we're going to use this inequality for both sides. Now, whenever you have greater than, instead of shading on the inside, we're going to be shading on the outside. Now the reason why we're shading on the outside is because, again, we can just write this out without the absolute value. And basically, x is greater than 5. Well, what numbers can I plug in for x that are going to be greater than 5? Well, that's going to be 6 is greater than 5, 7. And you can see that we're shading on the outside. That means on the other side, same thing. When we use the absolute value of x greater than 5, these negative numbers are, the absolute value of these negative numbers are going to be greater than 5. Okay, so we begin going over this, right, solve and graph absolute value equations, and today we're going to finish covering this, or probably review it, and then we're going to finish the second learning target, which is to solve and graph absolute value inequalities. Okay, so just to recap, when we were solving absolute value equations, the very first step that you always want to do is to isolate the absolute value expression. So basically, well, let's go to step 2 and then I'll show you what I mean. And step 2, after you isolate the absolute value expression, you write two equations from the absolute value equation. Alright. So, step 1. We want to isolate the absolute value expression. Very specifically, I want to get these, whatever's inside the absolute value, or this absolute value expression right here, I want to get it by itself. Right now, I have this 2 right here, I'm multiplying by 2, and I have this negative 5 right there. I don't want those there. I want to get rid of them, move them to the other side so that this is by itself. Okay, so what do I need to do? Well, again, you always want to follow reverse Pemdas, or as what one of my students said, sad MEP. But I think I will call it reverse Pemdas. Reverse Pemdas, okay. So, reverse Pemdas, the first level is addition, subtraction, multiplication, division, exponents, and then finally last, parentheses. Parentheses or absolute value. So we'll include absolute value in there. Okay, so do I have any addition or subtraction going on here? Well, yes, I have this subtraction. Do not look at this because this is inside the absolute value. That level is last. So since I have negative, I'm subtracting 5 here, I need to do the inverse, the opposite, which is to add 5. Remember, whatever I do to one side, I have to do to the other side. So I have 2 times the absolute value of x minus 1. That becomes 0, and we have 6. Okay. Keep going up the reverse Pemdas. No more subtraction. I don't have addition. I don't have division, but I do have multiplication. So I'm multiplying by 2 here. The inverse or opposite of multiplying by 2 is to divide by 2. This basically becomes 1, so I just have x minus, the absolute value of x minus 1 equals 3. So is step 1 complete? Did I isolate the absolute value expression? Is this by itself now? Did I get rid of the 2 and the negative 5? Yes, I did. Step 1 is complete. Okay, that brings us to step 2. Write two equations from the absolute value equation. That means that I'm not going to have an absolute value anymore. I'm going to go have basically two equations. And I want to be very specific about this. Basically, whatever's inside the absolute value is going to stay the same. This right here is where the sign is going to change. So that stays the same. That is going to change. So here's what I mean. X minus 1, still the same. We have positive 3, or x minus 1, that stays the same, is equal to, this time, instead of having positive, we have negative 3. There we go. That is very important to always follow that. Where one is positive, the other one is negative. Do not change anything here. The sign does not change. Okay, so now we basically take a look at each of these individually and solve for x. So here we have to add 1 to both sides, and so we have x equals 4. Or here we have to add 1 again to both sides, and here we have x equals -2. Those are our two solutions, 4 and -2. That's basically it. Now, we did go over this example right here. There's something that I wanted to emphasize here. This I covered basically in the previous video. I'm just going to summarize what we went over. Here. So what I said in the last video is that basically this number right here, this 1, well, take a look at your two solutions. Here are my two solutions. What is the midpoint of those two solutions? Where is that point in the middle? Well, it's basically 1. Now, do we see 1 anywhere in this absolute value equation? We basically have -1 here. So if we take the opposite of whatever's in here, that is going to give us the midpoint or the target. The target is basically the opposite of what's inside. The opposite. It's always going to give us a target. And then notice that from the target we are 1, 2, 3 units away. There's 3 units away going this way, and 1, 2, 3 units away going to the left. So we can see that we have a 3 right here, and so this is what varies. From the target, the solutions vary 3 units away to the right and 3 units away to the left. So that's a very important idea. So here, let's just take a look at try these B real quick. The pH of water is a measure of its acidity. The pH of water on the seal slide can vary. This is a keyword, you may want to underline that. Can vary up to 0.3 from the target. That's also another keyword, target pH of 7.5. Use this information for parts A through C. A. Write an absolute value equation that can be used to find the extreme pH values of the water slide on the seal slide. Be sure to explain what the variable represents. Well, let's take a look back at what we had here. So basically we want to go ahead and set this up, our absolute value equation. Well, let's keep using the variable x. And remember, what goes here? The target goes inside the absolute value. Now remember, the target always has the opposite sign. So if we have a target of 7.5, then since this is positive, it has to be the opposite. So it's going to be minus 7.5 inside the absolute value. Okay. And we also have what varies. What varies goes here. So we have 0.3. That is what varies. Okay. So now we can go ahead and solve the equation, interpret the solutions. Remember, the fundamental idea here is to take this right here. That stays the same. Here, since this is what varies, that's what changes. So x minus 7.5 equals 0.3, or x minus 7.5 equals negative 0.3. If we go ahead and solve each of these for x, we have to add 7.5, and so we have x equals 7.8, or we have to add 7.5 here too, and so x equals 7.2. Okay. Now, what I really want you to do is interpret the solutions. Interpreting the solutions, I can't stress this enough. This is very important. let me tell you what I mean here. Here we have 7.8, and here we have x.72. Those are numbers. Those are solutions to an equation. But what do they mean? If I were to walk up to a person, and if you were to walk up to a person and you say x equals 7.8 and x equals 7.2, that person is not going to understand what you're talking about, and that person is going to walk away. Not much of a conversation, is it? So that is what I mean about interpreting your solutions. Let's take a look at what does 7.8 and 7.2 represent. Well, we're talking about the pH of water. So we have a pH of 7.8, and then we have a pH of 7.2. Okay, but is that much of a conversation? Again, you go up to a person and you say pH of 7.8 and pH of 7.2. That person is still going to walk away and is probably never going to talk to you again, because this is not much of a conversation here. What do you mean by pH 7.8 and 7.2? Okay, so we need to look at the details here. The pH of water is a measure of its acidity. The pH of water on the CO slide, well, we're starting to get somewhere. On the CO slide can vary up to 0.3 from the target of pH of 7.5. So we're talking about the CO slide and the acidity of the water. So those two numbers, if we look at A, the extreme pH values. So now we have some information here. So let's go ahead and create a sentence here. So here is the perfect answer. The acidity, I don't want to spell this right, acidity of the water on the seal slide can vary from a pH of 7.2 up to a pH of 7.8. There we go. This is a sentence. This is a conversation. This is something that you can come up to a person and say, and that person is not going to walk away. So don't just give me the answers to the solutions. I want you to tell me, what do you mean by those solutions? You want to have a conversation that makes sense. Alright. Okay, now we're going to go ahead and focus on solving absolute value inequalities. Now, basically what we want to do is take whatever's inside the absolute value and put that in the middle, x minus 2. Now, this is what's going to vary. That's what's going to change. So we have negative 3 and we have 3 on the other side. This absolute value symbol, this inequality, which is less than, is going to go on both sides. So there, we have our inequality set up. It's basically the idea that I had you do for your warm-up, where here I told you to take whatever's inside the absolute value, put it in the middle. Whatever's here basically goes on both sides, but one is negative, the other one is positive. This negative one goes on the left, the positive goes on the right, and the absolute value stays inside. And then whenever it's less than, it gets shaded on the inside. Whenever it's greater than, it's going to be shaded on the outside. So we're following those same ideas for this type of inequality here. Now, we can't go ahead and take this number and plug it in on our number line. We can't say that we have 3 and we have -3. The reason why is because we don't have x by itself. We're subtracting 2 from x. So we need to actually solve this like an algebra problem to solve for x. So since we're subtracting 2, the inverse is to add 2. So in this case, whatever we add 2 to one side, we have to do it to all 3 sides. So we add 2 here, and then we add 2 there. Okay, -3 plus 2 is -1, which is less than x, which is less than 5. Here are my 2 solutions. So we have, now remember, we have less than, going all the way back to my box. If we have less than, we're going to use open circle. So less than, open circle here, and then 5, open circle there. Alright, now again, since we have less than, going all the way back to our warm-up, if we have less than, we shade on the inside. If we have greater than, we shade on the outside. So let's go all the way here, and we're going to shade on the inside. So there's 2 things that you want to do. You want to have your inequality, and then you want to have your interval graphed. Alright. Now here's the level we want to build up to. So we start from the basics, and here is the type of question that we want to be able to solve in the end. Not an equation, but inequality. So the very first thing we want to do here, you don't want to make the mistake of saying that this goes in the middle, 2x plus 3, and then write your inequalities and put -6 and 6. You're missing something here. So we have to follow a first step, and this is actually the same step as solving an equation. So step 1 is to isolate the absolute value expression. You want to make sure that this is by itself. Is this by itself? Nope. We have this +1 here. We want to get rid of that 1 and move it to the other side. So this is the same step as solving an equation. So we need to go ahead and subtract 1. Now we have the absolute value of 2x plus 3 is greater than 6 minus 1, which is 5. Now we have, step 1 is complete. Now we have the absolute value isolated. Now step 2 is going to be different than when you're solving an equation. Here, what you actually want to do is not write 2 equations from the absolute value. You want to write the compound inequality. Write the compound inequality. So basically, that's what I've been repeating various times. What you want to do is you want to take whatever's inside the absolute value and put it in the middle. 2x plus 3, and then this is where the sign changes. This is what varies. So we have -5 on the left, that the negative goes on the left, and then the positive goes on the right. This inequality basically goes on both sides. Now don't make the mistake of saying that we have -5 here and we have 5 there. We need to solve the compound inequality. So I'm going to write the compound inequality and solve. So you need to solve this. So this is basically just an algebra problem. We need to solve for x. You want to use reverse Pemdas, so you start with addition or subtraction, and we need to, since we're adding 3, we need to do the inverse, which is to subtract 3. Negative 5 minus 3 is negative 8, which is less than 2x, which is greater than 2x, and 2x is greater than 5 minus 3, which is 2. Alright, now here we need to, since we're multiplying by 2, we need to divide by 2, do the inverse or opposite, do it all to all 3 sides, and what we have is negative 8 over 2, which is negative 4, which is greater than x, which is greater than 1. Okay, so here is our inequality. You have to follow these 2 steps. Now we can go ahead and put our 2 points on there. Since we have greater than, going all the way back to my box, since I have greater than, I'm going to use open circle. So we have an open circle on negative 4, and we have an open circle at 1. Remember, once we have our absolute value isolated, if the absolute value is greater than whatever number is here, that always means we're going to shade on the outside. So that's following from the do now. When the absolute value is greater here, we're going to be shading on the outside. So let's go ahead and shade on the outside. So you always need, so here are our final answers. You want to have your inequality, and you want to have your shaded graph. Okay, so basically I have you doing A, B, C, and D, and just as a reminder, you're going to have to do page 14, number 6 through 14. That is going to be due on Wednesday. Alright, thank you for watching.